The secondary process at Estero centers on biological treatment by using a community of microorganisms to consume nutrients in the influent water. Specifically, the plant uses suspended growth reactors to perform the biological treatment. These reactors take the form of aeration basins, six 170-foot long aerated tanks that contain a suspension of microorganisms, water, and nutrients called mixed liquor. The mixed liquor is the dark brown colored water seen here, and its rich brown color indicates a healthy biomass. These tanks are where the microorganisms, or bugs, do the magic of the treatment process. Very similar to humans, the bugs eat and breathe. They take in food and oxygen, turn that into energy in more bugs, and breathe out nitrogen gas and carbon dioxide. Their food is provided by the influent water to the plant, and the oxygen is provided through millions of tiny air bubbles pass through the basins. The bubbles are created when compressed air passes through any of the 6,000 different diffuser discs within the aeration basins. The purpose of these diffusers is to create very small air bubbles to promote efficient transfer of oxygen to the water. The cornerstone of the secondary process is the amount of biomass in the system at any given time, and is typically measured in pounds. Biomass can be pictured this way. If all the water in the entire secondary process were to suddenly evaporate, the biomass would constitute about 80% of the material left over. The secondary process operates based on the total amount of biomass in the system, because it determines what sorts of bacteria thrive, and ultimately what kind and how much of the nutrients are removed from the water. Equally important for plant operations is to provide the bugs with the right combination of food, oxygen, and time within the plant. However, if left unattended with these conditions, the bugs would multiply to an unhealthy extent. To control their growth and maintain a desired concentration within the basins, operators waste a certain mass of microorganisms daily that approximately equals the growth rate of the bugs. Wasting the biomass means sending it to the solid system, where it is further processed and ultimately turned to methane gas and biosolids. From the aeration basins, the water enters one of the 7 secondary clarifiers. Very similar to the primary clarifiers, the secondary clarifiers work on the principles of sedimentation and decanting. A common household example of decanting deals with wine. As red wines age, for example a port, they accumulate solid crystals at the bottom of the bottle that can be bitter. To prevent these crystals from suspending in the glass, a bottle is typically stood upright for a day prior to consuming, and then the top liquid is poured off without disturbing the solids on the bottom. In the same fashion, the clarifiers work by allowing biomass to sink to the bottom of the tank, while clear water pours over the top of stationary weirs and exits the tanks. The solids are collected and removed from the clarifiers by a series of scrapers that run along the surface of the water and bottom of the tanks. The floating material is called scum, and the sinking material is called sludge. The scum is sent to the solids train, and the sludge is returned to the head of the aeration basins to maintain the biomass concentration. From the weirs, the clarified water goes up to 3 different directions: to the secondary effluent return, to the tertiary system that produces reclaimed water, or to the disinfection chamber, which adds sodium hypochlorite or bleach to kill any remaining pathogens before discharging to the ocean.